Hello, this is FlippedHarber for Algebra 2. In this video we'll cover section 3.5, linear equations in 3 dimensions. Our objectives for this lesson are to graph points in linear equations in 3-dimensional space. Our topics will include linear equations, systems of linear equations, 3-dimensional coordinate system, an ordered triple, and we'll introduce what the z-axis is. Now let's take a look at what we refer to as the XYZ coordinate system. Now you're very used to seeing the XY plane, but that's only in 2 dimensions. So we have to try to represent 3-dimensional space on only 2-dimensional paper. And we do it with this type of drawing that we call an orthogonal view. We're supposed to be looking at this kind of from an angle. Now notice the labels on our 3 axes. We would expect that up and down line to be the y-axis. That's what it normally is when we're in 2-dimensional space. But notice it's labeled z. That line that's going left to right, we would normally label that the x-axis. But in our XYZ coordinate system, that's the y-axis. Our x-axis is drawn at this weird angle. And the idea behind this is it's supposed to be coming out of the paper at us. Now this is a challenge for a lot of people to see. You kind of have to get used to it. Look at it and let it roll around in your head for a while. But that x-axis that's labeled down and to the left is actually supposed to be coming out of the paper at you. So you're going to have to get used to drawing this. You're going to have to get used to labeling it. It's going to seem weird for a little while. Now, graphing points in this is going to seem even weirder. And points are now in what we refer to as ordered triples. The first number is always our x-coordinate, that is how far we move along the x-axis, and then our y-coordinate, and then our z-coordinate. So it's going to be really, instead of left, right, up, or down, we're going to talk about moving out or in, that's along the x-axis. You could say forward or back. And then we're going to move left or right along the y-axis, and we're going to move up or down along the z-axis. Now, plotting points, plotting ordered triples, what I want you to do is draw the path that you see. So we have 3 points here, A, B, and C, drawn in 3-dimensional space. Now, we've also drawn the path that's followed to get from the origin to the point. This is very important. You too must draw the path to get from the origin to the point. So the point A is 2, 3, -2. So if you start at the origin and follow the blue line, you go out the x-axis. Now the positive x-axis is pointing out of the paper, so you move out 2 points, and then you move right 3 points. So we're moving parallel to the y-axis 3 units, and then we move straight down, that is the negative z direction, 2, and we mark the point. The point B is -1, 1, 2. So starting from the origin and following the red path, we move backwards or into the paper -1. Then we move right 1. And then we end by moving up 2. And that's the point B, -1, 1, 2. Now see, we move back 3, left 3, and then with a z coordinate of 0, we don't move up or down, we just mark the point. Now remember, you have to draw the path. Don't just plot the point. Draw the path that gets from the origin to the point. Now, let's try graphing the point -2, 3, 1. I'll draw the path as we do it. So we have to move backwards into the paper along the x-axis -2. So I'm doing this in red, and we move backwards 2. Now we're going to move along the positive y direction 3 units. So we're going to move right 3, and then we have to move straight up 1, and that's our point. I've drawn the path, I've marked the point. Let's take a look at the point 2, 4, -3. we're going to move forward 2, we're going to move right 4, and now for a z-coordinate of -3, we're going to move down 3. So we've drawn the path and we've marked the point. Now, graphing a linear equation, 3x plus 4y plus 2z equals 12, in three-dimensional space is not that bad, because what we need to do is find each of the intercepts, the x-intercept, the y-intercept, and the z-intercept. Now, in order to find the x-intercept, we plug 0 in for y and z. We get x equals 4 in this case. To find the y-intercept, we plug 0 in for x and z. We get y equals 3. To find the z-intercept, we plug in 0 for x and y, and we get z equals 6. Now, these are x, y, and z intercepts. That is, that they're points on the x-axis, the y-axis, and the z-axis. So we mark those 3 intercepts, and we draw a dashed triangle between them. This quadrilateral that you see here is the book trying to show this plane that goes through these 3 points. You do not draw that. You just draw that dashed triangle. So let's try another one. Let's draw the three-dimensional equation 10x plus 15y minus 6z equals -30. We find our 3 intercepts. We plug 0 in for y and z. We find out that x equals -3. We plug 0 in for x and z. Y equals -2. Plug 0 in for x and y. Z equals 5. So these become 3 points to mark on the x, the y, and the z axis. Connect them with a triangle, and you're all done. Okay, hopefully you didn't think that that was too bad. Just a little bit of graphing to do, and you're all done. So, time to get to work. I'll see you in class, and I'll see you online.